Are we alone in the universe? This age-old question that has puzzled humanity for millennia might finally have an answer. In August 2025, an international research team announced a groundbreaking discovery, a super-Earth named Kepler-7 25c, located within the habitable zone of a Sun-like star. It not only could potentially have liquid water, but might also possess the conditions necessary for life. Today, let's unveil the mysteries of this extraordinary planet and explore why it has captivated the scientific community. The discovery of Kepler-7 25c was no accident. It was made possible by a pioneering detection technique, the transit timing variation (TTV) method. Unlike traditional methods, TTV analyzes the slight variations in transit timing of a known planet, Kepler-7 25b, to indirectly infer the existence of another hidden planet. This method doesn't require the planet's orbit to align perfectly with our line of sight, nor does it require direct observation of the star's radial velocity, making it especially suitable for detecting long-period, low-mass exoplanets. More importantly, this discovery is a model of international cooperation. Institutions such as the Yan'an Astronomical Observatory of the Chinese Academy of Sciences, Hamburg Observatory in Germany, and Xi'an-Jiaotong Liverpool University work together, supported by the National Natural Science Foundation of China and the Chinese Human Spaceflight Program. This not only marks a technological breakthrough, but also showcases human wisdom and unity in the pursuit of cosmic exploration. What is the habitable zone? Simply put, it's the area around a star where liquid water can stably exist. Not too hot, water would evaporate, and not too cold, water would freeze. Just like the Goldilocks zone in the fairy tale. Kepler-7 25c's semi-major axis is 0.674 astronomical units, about 100 million kilometers, with an orbital period of 207.5 days, receiving about 1.4 times the stellar irradiation that Earth receives. This positions it squarely in the habitable zone of its Sun-like star, G9V type. In contrast, previously discovered habitable planets often orbit red dwarfs, smaller and dimmer than the Sun, while Kepler-7 25c's host star is more similar to the Sun, greatly enhancing its habitability potential. However, being in the habitable zone is just the first step. Here are 3 key factors to consider for life to potentially develop. 1. Atmospheric composition. If the atmosphere contains water vapor or methane, biosignatures, the potential for life on Kepler-7 25c would greatly increase. However, keep in mind, water in exoplanet atmospheres might be common but scarce. A 2019 study from the University of Cambridge showed that many planets' atmospheric water content is much lower than expected. 2. Presence of water. Liquid water is the source of life. Theoretically, Kepler-7 25c has temperatures suitable for liquid water, but further exploration is needed to ascertain its actual distribution. Planets like K2-18b have been detected with water vapor in their atmosphere, but this doesn't necessarily indicate life. E.g., Venus has water but is uninhabitable. 3. Stellar activity. Kepler-7 25c's host star is a G9V type, similar to the Sun and relatively stable, reducing the destructive impact of flares on the planetary environment. In contrast, Planets in red dwarf systems often face lethal radiation from stellar flares. Let's compare the specifics, similarities. Orbits a Sun-like star, offering high environmental stability, located in the habitable zone, with temperatures suitable for liquid water. Differences: Kepler 725c is more massive, 10 times Earth's mass, possibly a rocky planet or mini-Neptune. Shorter orbital period, with a year lasting only 207 Earth days. Receives higher irradiation, 1.4 times, potentially leading to slightly higher surface temperatures. This discovery has electrified the scientific community. Nature Astronomy hailed it as a game-changing step in the search for Earth 2.0. Why? 1. Methodological breakthrough. TTV technology opens a new channel for detecting habitable planets, which will support missions like China's EDI satellite and Europe's Plato satellite in the future. 2. Target closer to Earth 2.0. Compared to Kepler 22b, 600 light-years away, discovered in 2011 with unknown temperature, or Gliese 12b, 40 light-years away, discovered in 2024, orbiting a red dwarf. Kepler 725c orbits a Sun-like star more akin to Earth's conditions. 3. Increased potential for life. Scientists speculate that if the atmospheric composition is suitable, Kepler 725c may be a prime candidate for humanity's search for an Earth replacement. Of course, challenges remain. At 2472 light-years away, our current technology cannot reach it directly. The atmospheric composition has not yet been directly measured and will rely on next-generation telescopes such as the Chinese Survey Stellar Telescope, VI. The discovery of Kepler 725c represents not just a scientific victory, but a testament to humanity's eternal curiosity about the mysteries of the universe. It reminds us, while Earth might be our only home, it might not be the lone hope in the cosmos. Now, let me ask you, do you think humanity will be able to truly find Earth 2.0 in the future? How should we respond to the discovery of extraterrestrial life? Share your opinions in the comments. Don't forget to like and subscribe to keep up with the latest in space exploration.